Hey coders and LeetCode enthusiasts. Today we are solving day 30 of March Daily LeetCode Challenge. Today we are solving question 992, subarrays with k different integers. Given an integer array nums and an integer k, return the number of good subarrays of nums. A good array is an array where the number of different integers in that array is exactly k. For example, 1, 2, 3, 1, 2 has 3 different integers, 1, 2, and 3. A subarray is a contiguous part of an array. So, this question is another subarray question like all the ones from the other days, and a brute force solution would be in O of n squared time, because there are n squared subarrays possible. However, we could use a sliding window technique like we always do and bring the runtime down to O of n. So how can we solve this question? Well, this question is a hard question, and we have to keep track of 3 pointers instead of 2. So let's call these pointers the left pointer, the middle pointer, and the right pointer. And it's quite similar to the question we did yesterday, this one. Question 2962. It's similar because we use 2 while loops. So we use 2 while loops. We could just solve it in 2 while loops. And one loop we do to make sure k is never exceeded. And the second loop is, so the first loop is to make sure k is never exceeded, and the second loop is to make sure there are no extra middle elements, if that makes sense. So let's dive further into these loops. So the first loop is to make sure k is never exceeded. How can we do that? So that means, so in order to make sure k is never exceeded, we would have to count the amount of elements in our hash map. I forgot to mention that we will need a hash map to count the frequencies of the elements in the array. So when the frequencies, or when the size of the hash map exceeds k, then we know that k is exceeded. And when k is exceeded, we have to move middle pointer forward until this is not the case. And also L pointer follows M pointer. So the left pointer will be in the same spot as the middle pointer in this scenario. And then the second loop is to make sure there are no extra M elements. So when there are more than one frequency of M, then we have to move M until this is not the case. And that's it. We just have 2 while loops. We introduced a new pointer, and that's really all there is to the solution. It's similar to our last problem. We used 2 while loops, and It's just a little curveball with the extra middle pointer. So let's talk about runtime. Runtime is O of n. We do one iteration. We do one iteration through the input array with R, and the space time is O of n because we have a hash map to count the frequencies. So that's why our space is O of n. So let's crack this one. So we need a hash map to count the frequencies of the elements in an array. So from collections, import default dig. So our hash map is default dig with a default value of 0. We have two pointers L and M, and we start them at 0. We need two while loops, so let's start our iteration of R. Lang nums. We will have to add this frequency into our hash map, so hash map of nums of R plus equal 1. And then we have to make sure k is never exceeded, so while m is not greater than k, so while m is less than R and k is not exceeded, and the length of hash map, so the size of our hash map is greater than k, then we know we have an issue, so we will have to start executing this while loop. So when this is the case, we have to move our middle pointer. So hash map of nums of m minus equal 1, m plus equal 1. So we are taking the value of the middle pointer out of the hash map, and then we're moving the middle pointer forward until k is not exceeded. So when we subtract from the hash map, if hash map nums m is equal to 0, then let's pop this key from the hash map. And now we need to make our second loop, so while there are no extra m elements, so while middle pointer is less than the R pointer and there are no extra m elements, hash map nums m. So if there are more than one frequencies for the m element, then we have to move the m element. It's just a copy. Oh, I forgot to say the left pointer follows the m pointer, so the left pointer will just be the m pointer. And then if k is equal to the length of our hash map, then our answer will just be the middle pointer minus the left pointer plus 1, and then we can return answer. So we are adding the middle pointer subtracted by the left pointer plus 1, as that gets all the subarrays from the biggest possible subarray that we found to the smallest possible subarray that we found. So we're just adding the difference, which is all the possible subarrays plus itself. So that's the plus one. And that is the solution. Okay, and I'm gonna submit. And there you have it, folks. Thank you for watching. This has been question 992. I will see you in the next one. Peace out.